Chapter 11, Heating. 11.1, Generating. The modern mat passenger is heated almost universally fine copper floor-mounted steam radiation system supplied by the locomotive. A well-constructed insulated car will use 25 to 350 pounds of steam per car per hour. In some cases, the passenger cars are heated by the split system switching, which includes overheated air circulation provided by the heating and air cooling floor-mounted standing radiation use of car sides. Some electrical trains, motor cars, and use of electrical cars resistant coils usually placed beneath and seats along the walls. The system most generally used for the type of used today, including the steam vapor zone, the straight vapor, and the direct seams of the pressure heating system, the vapor zones system of the use of high pressure. The other use of systems of low pressure. The steam vapor and system is controlled manually, and other parts are automatically controlled, varnished, and thermostatic, electrical energized vaporish. The steam vapor, the vapor system, is the most Army-owned passenger cars. 11.2. The steam line connections. The flexible metal conduity of Figure 11.1. Each of the conduities permit the connection of the line of the adjacent car. The one in each of the conduity connections of the car steam heating line. On the other end, equipped with the steam coupler, connects to the similar coupler of the metallic conduity of the adjoining car. The steam coupler includes a body of spring on the spring flanges, the lugs, and means of interlocking connections of the couplers are steam lime tight. And the end of the type of train light provides a means of shutting off the steam of the main steam of each end of the end of a car. The conduity includes the end of each connector on the upper body and intermediate casting of the lower body, and under the coupler adapter. The coupler adapter is joined in the lower body and means of a sleeve type of the joint. All these parts are connected onto the form of complete unit of the steam type of the ball type joints are permanent to the conduity to just an irregularity. 11.3. Pressure reducing valve. The pressure reducing valve located in the locomotive provides a means of maintaining, predetermining, reducing pressure of the train steam heater line. The outside temperature is normal of the cars in the train, and the factors governed by the pressure desired by the steam is emitted by the two chambers of the valve, and the passes of the unseated auxiliary valve in which it is held. The end of the valve connector, the upper body, the intermediate casting, the lower body, and sleeve in the type of joint, and the coupler adapter. Flexible metallic conduity. Open to the spring-loaded diaphragm, and pressure increases to these chambers, and the piston is moved within the forces of the auxiliary main level pressure, and the reducing valve steam under the pressure is permitted to move upward and exert pressure in the spring-loaded diaphragm. Auxiliary valve is enclosed, and as the steam condenses, pressure is reduced. The spring is again exerted to the auxiliary valve, opens it, and simultaneously opens and closes in ports as required. The spring and spring-loaded diaphragm can be adjusted to exert and desired pressure. 11.4. Steam vapor per system. The steam of the atmospheric pressure is steam vapor is the sea level temperature of 212 degrees Fahrenheit. A theory of the steam condenses the water and given off the same amount of the heat that is required to convert the water to steam. Therefore, the maximum quantity of the recoverable when vapor in the 212 condenses the water at the temperature imposing of the drain of the boiler of the heating source of the vapor system of the steam heated system obtains the vapor of the locomotive or the flashing boiler, and delivery and controlled by the pressure regulator. The regulator controlled by the manually a locomotive open and closing cut out vapors regulated or mounting steaming energy steam entering the car radiator system. The regulator generally is set delivery system approximately 15 pounds of pressure per the car of the train, and if diesel operations the system source of steam sometimes is. This is a pressure reducing valve. This is chamber number 1 is auxiliary valve. The main valve, the passage from unseated auxiliary valve, the spring loaded and diaphragm, and on chamber number 2 in pistons. Contained with a special construction heated in the carrier at the end of the train. In figure 11.3, the vapor system on one of the side of the passenger car is shown and provided manual controls and identical systems employed on the other side. The system consists of a steam line underneath the car and vapor regulator. Also on the underside of the car, the two vapor cut out of the valves and the heating coils are the car supply. The vapor regulator and connecting the steam line branch line pipe and constant pressure valve with a standard cut off of the valve installed. 11.5, the vapor zone contained in the manual manual system of vapor zone is given by the base. Better distribution, heat, and more uniform temperature, and through the car makes more economical use of steam. The system of the car divided in two or more zones of the area, in each of these which is filled with fitted with the steam of the radiation system. The flow limit valve independently thermostatically controlled radiation, usually in the fin type, may be located under the floor overheated one zone diaphragm type of heating system shown in 11.4. 11.3 is a hand-operated vapor system, and the condensing discharge vapor regulator steam line, and then from the condensation discharge of the vapor regulator to the branch pipe and to the drainage pipe. On top, you got two heating coils from the heating coils manually operated from the vapor cutoff valves and the steam line. This is a hand-operated vapor system. Here's in 11.4 we have a radiator, steam admission valves underneath the seats, radiator with water seating fittings going at every seat where the radiator is at from the steam emission valves. There's a pitch circuit track, a vapor retarders, steam supply loop. That's the steam supply loop. It goes one way and another around the other way through regeneration of the radiators. The vapor retarders underneath the seat, they go up and down. They're like branch type. And drain tube, the constant pressure valve, a flow limit valve, a manual control, a shut-off valve, and a train pipe. Figure 11.4, zone B. 11. We're in 11.5B. Essentially, the vapor zone of the heating system consists of one more steam supply loops of loops of the pipe underneath the car. Each loop is supplied by the single vapor regulator. Release of the live steam from the train pipe and converts in the vapor of 225 degrees. The steam loop furnishes of steam vapor into two or more radiators that are extended to the surface of the unit fin type of the system training line conducted by the train line strainer T-cross of the vapor regulator, which is to reduce the pressure by 40 pounds and shut off the drain, and is placed in the regulator to permit the steam from the vapor regulator steam supply loop to be shut off if required. See if each steam supply loop is controlled by accordance with the steam requirements of the floor valve incorporated with the regulator. Steam loop is divided in feed portion, return portion of the vapor loop, and retarded created aids the reservoir steam of the feed and portion of to ensure the immediate delivery of the steam and radiator whenever the radiator and the steam emission valves are open and the radiator is condensed and is piped and returned in portion of the loop and condensed it when the open conditional atmospheric through the return of the pipe of the drain and through the adjacent regulators. One of the type of automatic temperature controlled by the vapor automatically operated with a vapor cutoff valve and employed installed in two manual operated valves previously discussed. 11.16 the direct steam and pressure steam. If direct steam system in the car heating and the steam from the locomotive is carried directly into the radiators or heating pipes of the cars, the heating is distinguishing steam through the steam vaporized before and entering the heating system and employed for the heating of the water circulates the radiator and the heating of the pipes and the hot water system is heated. 11.7 the electrical heat. The electrical motor cars are the most commonly heating is used by resistant coils used by placing beneath the seats or along the walls. The coils beneath the heated and electrical current is passed through the heat and transmitted surrounding of the car, and the sectionized varying degrees of the heated beam may be obtained. The car's operated in direct current is customary used in the line voltage of the heated and alternating current cars, and transformer is employed in the cut down of the voltage from the heater usage. This is an automatic controlled vapor system. Up top you see the fine radiators, the magnet cutoff valve to the drainage pipes, the branch pipes, and then in the flow circuit, the vapor regulator, and up and into the constant pressure valve, with the cutoff valve, the drain pipe, and in the vapor regulator you'll see condensation discharger. 11.8. The maintenance and repair. The two essential factors of the steam heat and maintenance, prevention of train delays, of the steam failures, and provision cars comfort from the passengers. The type of maintenance must be often performed for the short layover. The period of terminal's maintenance program will include the inspection annually, preferably prior to the beginning of the heating ascension season. For the principal sources of trouble for the discussed below, ending the train pipe of the valve should be operated in platform. Linkage is in operating condition as always, weighted to the ball type of the handle. So you check out the hold on the valve, and the most common valve is the steam will be needed to replacing the addition of the packing ring. The stem will need the repacking of the addition of the packing ring. The stem should have sufficient packing, subsequent packing and nutting tightenings can be made in the car inspections as required. When the car is stopped, the valve should be disassembled and checked where the particular main valve and seated bleeder valve and the pin cams and the levers should be checked with the wear upon reassembly. The valve should be tested. High pressure steam for the leak of the proper function. See the strainer. The strainer located at the strain line crosses the T should be removed and cleaned when the car is shop. Normally, this is adequate attention. D. The vapor cutout and drainage valve. The cutout and the drain valve located in each branch pipe should be not required for maintenance, and they're thoroughly overhauled and car is shopped. And consistent with the steam leak existing in the drain port is usually indicative of a faulty back seating of the valve. This can be corrected by grinding the seating in the seat. Should be tightened by the valve in open position. E. The steam couplers. The steam blows in a joint indicating the broken lugs and the faulty gasket springs, locking lever, and replacing the entire coupling in one necessary. Constant pressure valve. 11.5. The valve should be removed and repaired and annually using a procedure as follows: assemble the valve and clean the inspection parts. And 2. Replace any part of it should be excessive wears of any of the springs loss of their tension. C. The inspection diaphragm carefully, particularly with the edge and continually flexing occurs. The cracks developing in the areas. 4. The checking of the need of the valve assembly. Ensure that the stem is true and the seat are not scored. 5. Replace the need of the valve, and if the valve is in seat, scored and withdrawn. C. The reassemble adjusting the constant pressure valve and the live steam pressure. G. The valve vapor regulator. Visual operation of the vapor regulator is sufficient with the ensure the proper function. The steaming leak of the regulator within the vapor valve is closed, and indication of the valve is not seating properly. When the worn valve is in seat or dirty is between the valve and seat may cause condition. A worn seat should be regrounded and replaced and dirted, and it may be blown out by closing and shutting off the valve ahead of the regulator for the few minutes of opening it again. The steam blows from the drain tubes and blows to the diaphragm damage before the heating season. Regulator should be tested under this pressure. Assure the operating rods are free of the guided nuts through the biennial overhaul. Includes disassemble, cleaning, and inspection of all parts for wear. C2. Replacing badly worn or damaged parts. C. Checking the spring tension, inspecting the gaskets. 4. Inspecting the regulator valve assembly, bellows, packaging assembly for the main bellows. Reassemble the regulator. Check on the steam lines, steam traps. Excessive steam bellows may be eliminated, changing the position and adjusting the screws and steam trap that cannot be properly adjusted. Should be disassembled and inspected in the following manners. 1. The removal of the strainers, assembly for the trap, inspecting the spring seat and spring, seat, and disc and diaphragm. The strainer replacing any defects. 2. The test diaphragm installation. The diaphragm extended too much and which will not and normally follow contracted with the cool and place diaphragm and holding fixture submerged in watering in about 190 degrees Fahrenheit. It was weak and indicated rising tubes rising bubbles. The leak diaphragm must be discouraged. No attempt will be made to refill and repair. After the test, submerge the diaphragm in cold water and to contract it. Remove it from a holding fixture. Reassemble the trap and check to see the adjusting screw pins caught in good condition. Testing the trap for the steam line at about 55 psi's. Regulating the adjusting screws for observing the excessive steam blows. I flow the limit of the valve. The valve should be checked for the repaired annually prior to the heating season and usually following the procedures. 1. To assemble the valve, inspecting the inlet of the valve assembly. 2. To go through the cleaning of the inlet valve assembly, particularly the strainer, assure the stem is free and the valve and the seat is seated and warm. If the inlet valve is non-seated, tightly in replacement of the inlet assembly, inspecting the gasket under the cap, see the body of the flow limit valve, the steam light, reassemble the valve and put it into low pressure steam, determining the pressure of which the valve opens. If the donut does not open in the correct pressure, replace the springs. J. Vapor retarder. The steam blower, the outer drain tube, and the regulator indicates a faulty vapor retarder. A vapor retarder is disassembled and cleaned and inspected at least every 2 years as follows: testing the thermostatic bellows of the leaks and placing a holding fixture, submerging the boiling water, and do not submerge expert in the fixtures and expanded bellows and will not return in normally fully contracted form. And low leaks, the bellows indicated by the bubbles rising to the water. The leaky bellows must be discarded and replaced. 2. The contract bellows of submerging cold water reassembly. The vapor retarder is ensure that the cap is steelite and the retarder is fitted. The gasket under the cap. The gasket is good in condition with the proper seated. Renew the gasket is required. Okay, the solenoid steam admission valves. It is essential that the wings and the bodies and thoroughly will be repairing the valve. The inside of the valve may be cleaned without removing it from the car. When the assembling of the valves in the car must be exercised alignment of the parts through the cleaning of the proper assembly of these valves, and between the shopping and the periods and little attention on occasional check of that for of operation. Some valves of the cutout type of the valves controlling the flow of the heating radiation normally are open for the closed electronically, and are the valves control steam overheated radiators. During the scheduled maintenance, the needed inlet valve should be replaced, and the seated and badly wired drawn sticking valve and will result. L. Terminal test. Steam heating equipment within tested car yards and determining the proper operation condition prior to the placing of the passenger car so that it is equipped in the train service. The following procedures should be followed. 1. Place a dummy coupling on one of the end of the car, connecting of the car to the yard steam supply on the other end. 2. Place a steam pressure 50 pounds on the line. Check out all shop valves and see that they are open. 4. Choke all the floor and overhead emissions. 5. Inspect all the regulators. Determine that they do not have a continuous steam blow. 6. Inspect all conduits and end valves of the branching pipes for leaks. 7. Move an emission to the on position set. The completing heating circuit is made in all coils. 8. On vapor loop of equipment, testing the loop, closing the all emission valves, checking all shut off and valves to determine that they are in the open position. If they are shut slightly below, the regulator indicates a faulty loop or retarder. If this heavy steam blow is noted, it indicates a bad valve and bellows of the regulators. 9. They open each and emission valve separately. Check for the blow of the regulator. The blow out occurs indicates a faulty retarder as a dirty seat of the particular coil. 11.6. Chapter 12. Air conditioning.